All right, so I am going to, I guess I don't need to give a little introduction to, like, as if I'm presenting to the cohort. I'm just going to jump right into the first objective. Okay, so this is the objective: identify and describe the steps of the scientific method. So chances are you've heard of the scientific method before. Maybe you've learned about it in elementary school or in high school or participating in a science fair. And for some, it might seem like a super complex or intimidating process that only highly trained scientists can do. But really, the scientific method is a natural and intuitive process of being curious, asking questions, and seeking answers about the world around us. And the scientific method is just a way of organizing your thoughts and following a set of procedures to gain knowledge about the world. It provides an objective framework to analyze data and come to conclusions. The steps of the scientific method can vary a bit based on the scientific discipline. So biologists, physicists, psychologists, they all might use it a little bit differently. And in general, there are about 6 steps. And these might be better referred to as elements because the order of these steps can be slightly different, or some steps can be combined, or some can be repeated again and again before coming to a conclusion. So let's go through them. First is the question. This is where you propose a problem to solve or propose something you want to learn about. Next is your hypothesis. This is a potential answer or prediction of the outcome to your question. Next is your experiment. This is where you test your hypothesis to prove it or disprove it. And next is results or observations. These are statements of knowledge gained through the senses or through the use of scientific equipment. Following this is analysis. And this is where you compare the results of the experiment to the prediction you posed by your hypothesis. And finally, you come to your conclusion. And this is where you sum up the findings of your observations and analysis, and you state whether your original hypothesis was supported or refuted by the data you collected. And depending on whether it was supported or not supported, you might start again. So let's go through some examples of the scientific method. So first, let's start with a non-science example. So let's say I'm in advertising and marketing, and I'm a marketer for an online store that sells t-shirts. So I'll start with my question. How do I drive more sales for these t-shirts from my online store? So my hypothesis might be, I think that telling my email list about how the t-shirt will improve their life will boost sales and help me to sell more t-shirts. So let's test this with an experiment. I'm going to send 2 different emails out. I'm going to send email A to half of my people on my email list and email B to the other half of the list. Email A is just a link to the online t-shirt store saying shop now. And email B might talk about how buying these t-shirts will improve your life because you'll look cooler and make more friends and be happier or whatever. And then you collect observations. So you observe how many people buy your product from email A versus email B. And then you analyze that data. Maybe you put it into a bar graph so you can visualize the data and see the number of t-shirts sold as a result of each email. And then conclusion, if more sales of your t-shirts came from people who clicked on email A or email B, then you can draw the conclusion of whether your hypothesis was correct and your method of driving t-shirt sales works. If not, then you might make a new hypothesis and go through the steps again. Here's another example that's a little more scientific. So let's say I want to figure out how long it takes to dissolve an Alka-Seltzer tablet in water. So start with my question. How do I dissolve Alka-Seltzer tablets the fastest? And my hypothesis might be, I think that the tablets will dissolve fastest in hot water. And so here's an experiment. Say you set up 3 different cups of water, each with different conditions. Say you do cold water from the fridge in one, and room temperature water from the tap in another, and hot water that you just boiled in a third cup. And you drop a tablet into each, and then you time how long it takes for each one to dissolve. And then next comes your observations, and you're timing how long it takes to dissolve each tablet, and then you write down the time that each tablet takes to dissolve. And then analysis, maybe you display those times in a graph or in a table so that you can look at it more easily. And then finally, conclusion. You can draw your conclusion based on which tablet dissolved the fastest. And if the tablet dissolved the fastest in hot water, like you hypothesized, then you proved your hypothesis correct. And if it didn't dissolve the fastest in that one, then you go back and make another hypothesis, and you could do the experiment again.